The next book I want to do is Elements of Non-Commutative Geometry by Gracia Bonda, Verrilli, and Figueroa. It is a book I got fairly early. I got this in my PhD because I was trying to read this book while I was doing my PhD thesis. So it has non-commutative topology, C-star algebras, non-commutative topology, vector bundles. It goes on about K-theory, Fredholm operators, Clifford algebras and spinors, spin representation, the non-commutative integral. It goes on to do non-commutative differential calculi, commutative geometries, spectral triples, Kahn's spin manifold theorem, tori, quantum theory, and Kreimer-Kahn-Moscovici algebra. It's a very good book. I like this book a lot, but it's obviously is a book for if you already know your stuff very well. See, here's the Gelfand-Naimark, very famous theorem. It does it really briefly. But he really explains the point of, here's the dictionary between topology and algebra, which this is the book where I learned this from, even though there are a lot of sources which do it as well. So this book, is if you're interested in non-commutative topology or non-commutative geometry in general, when it relates to C-star algebras, I think this is really the book that you will want to be doing. Very good book, very in-depth, and yeah. The next book is Barrett O'Neill, Elementary Differential Geometry, which is basically a differential geometry book, but it is, while it says it's elementary, it's from a quite nice perspective. So it starts with frame spaces. He does Euclidean geometry very nicely with the Klein point of view, calculus on a surface, the shape operators, geometry of surfaces, Riemannian geometry, and global structure of surfaces. This is basically a different book than Do Carmo, but it's kind of replaceable by it. So it treats things very analytically, and it uses the methods that you may know from advanced manifold theory. So he already uses forms, which is something that books of that level usually don't do. It's a very nicely written book, and I think I got a lot out of it. But I guess if you're interested in differential geometry, I probably would not recommend this book too much. There are better books out there, not that it is a bad book. Here we have Lee's Differential Geometry, but it's a different Lee, it's Jeffrey Lee. Manifolds in Differential Geometry. It's a graduate book. It's very much like other Lee, like John Lee, and it covers differential manifolds. It covers the tangent structure, immersions, submersions, curves and hypersurfaces, Lie groups, fiber bundles, tensors, differential forms, integration and Stokes theorem, the Ram cohomology, distribution and Frobenius theorem, connections and covariant derivatives, Riemannian and semi-Riemannian geometry. So like the other Lie, this it's very similar book to the other Lie book. Very much the same theory. I would say it's almost entirely similar, just a different way of explaining things. I honestly think he got a book because people would confuse him with the actual good one, the actual good author Lie, and not this one. So people buy the mistake. But no, it's not a bad book actually. It's a pretty good book. I like it a lot. But yeah, if I had to choose between this one and John Lee, I would probably choose John Lee anyway. But this is good. Here we have Shafarevich, Basic Algebraic Geometry, Varieties in Projective Space. Again, this is a book I got during my PhD. And it covers basic notions, so rational functions, projective varieties, quasi-projective varieties, local properties, blow-ups, normal varieties, singularities, algebraic groups, plane cubic, divisors, differential forms, intersection numbers, algebraic appendix. Then in book 2, which I don't have, there's schemes, there's varieties, And then in book 3, there's topology of algebraic varieties, there's complex manifolds, uniformization. So yeah, I don't really like this book. I think his way of explaining is a bit off. I really don't like it. Or maybe it's just me not liking algebraic geometry, not too much. But yeah, I didn't really particularly care for this book. In fact, I had a really tough time during my PhD to find any algebraic book that I really like. Again, maybe it's just because the field is not for me, or maybe it's because all books are crap, I don't know. Here we have Sharp, Differential Geometry. I got this book because of Klein's Erlangen program, which I really like, and I want something related to that. So this deals with Klein's Erlangen program, which classifies geometries in terms of groups. But now it's curved geometries instead of Klein. Klein was all flat geometries. So we see differential topology, we see foliations, we see fundamental theorem of calculus, Klein geometries, Cartan geometries, Riemannian geometry, Möbius geometry, projective geometry. It's kind of a niche book. If you're interested in this kind of stuff, in Klein's geometry, then I would definitely read it. Otherwise, you might probably want to skip it. But yeah, it's nicely written. It's not bad. If you're into geometry, it's definitely worth a read, I think. The exercises are not too difficult. But yeah, any differential geometry can be quite confusing. Here's a book that Krim will know well. Garrity, Algebraic Geometry, a problem-solving approach, one of my favorite algebraic geometry books. And it is no theory, it only has problems, a lot of problems, starting from very simple. So the very first chapter is on conics. Very simple, it starts very simple, but it does go into topology of conics and number theory. Then it does cubic equations, elliptic curves, higher degree curves, affine varieties, projective varieties, and sheaves and cohomology. So it starts very, very, very simple, finding intersection between a line and a circle. But it gets advanced really quickly. And in the end, it does sheaves, it does cohomology, it does all kind of that good stuff. So it goes from very easy to a very advanced perspective. It gets you to a point where you can read an actual schemes book very well and very easily. Next is Sosinski's Geometries. Again, one of my attempts to find... No, this actually does both groups and geometries in a nice way. So it's Euclidean geometry, certain toroid geometries, abstract groups, finite subgroups of SO3, Platonic solids, discrete subgroups, an isometric group of the plane and tilings, reflection group and Coxeter geometries, spherical geometry, Poincare disk model of hyperbolic geometry, Poincare half-plane model, the Cayley-Klein method, hyperbolic trigonometry and absolute geometry, history of non-Euclidean geometry, projective geometry, projective geometry is all geometry, finite geometries, the hierarchy of geometries, morphism of geometry. So this is definitely a book that I want to recommend to Crimson. I think you will be very interested in this. It's really mixing geometry with group theory and with algebra. It has no combinatorics though, but I think you will be very interested in a book like this, where they really go all out in the algebra and in the geometry. Very nice book. Definitely willing to work through this with somebody. It's very nice. Next you have Perrin's Algebraic Geometry. And it deals with affine algebraic sets, projective algebraic sets. It goes on to sheaves and varieties, dimension, tangent space and singular points, Bezout's theorem, sheaf cohomology, arithmetic genus of curves and the weak Riegemann-Roch theorem, rational maps, geometric genus and rational curves, liaison of space curves. So this is just a run-of-the-mill algebraic geometry book. I'm not sure I would really recommend this too much. There are better books on the market, but yeah, it's okay. Next we have Projective Geometry by Lawrence Edwards. It's, like it says, it's about projective geometry. So it has duality, it has collineation, cross ratio, correspondences, the conic, growth measure, circling and step measure, involution, pole and polar, dual property of curves, pencils and ranges of conics, the imaginary, the nature of a curve, the imaginary part of a conic, 4-point system with imaginary elements, projective idea of a circle, imaginary circle, 4-point system of conics, higher order curves, path curves, oscillating conics, fundamental notion for geometry in space, the quadric, the imaginary part of a sphere, the twisted cubic, more developables, the linear congruence and the tetrahedron, and perspective. So yeah, very in-depth book and on synthetic projective geometry. If you're interested in projective geometry, not from the algebraic point of view, but from the synthetic point of view, highly recommend this book. Very nice book. Very classical book. This is not the kind of thing that's being taught anymore. But yeah, it's nice. Doesn't have exercises though. Oh, it does exercises. Next, we have MacLean and Moerdyk's Sheaves in Geometry and Logic, which is a book on topos theory. So this is a bit advanced Goldblatt. Definitely a book worth doing if you already went through a topos theory book. So it has categories of functors, sheaves of sets, Grothendieck topology and sheaves, first properties of elementary topoi, basic construction of topoi, topoi and logic, geometric morphisms, classifying topoi, localic topoi, geometric logic and classifying topoi. So this book is all about a very advanced topos theory in a very advanced manner. This book is really famous, and anybody who is an expert on topos theory has read through this book. It's very famous book. Another geometry book. This time it's Do Carmo. It's differential geometry of curves and surfaces. Do Carmo is of course the most well-known undergraduate differential geometry book. So it has curves, it has regular surfaces, it has geometry of the Gauss map, intrinsic geometry of surfaces, global differential geometry. So this is probably the book you want to do if you want to get into differential geometry of curves and surfaces. It's very nice, very good exercises, very good theory. Yeah, it's basically has everything you want. I'm not sure I would really recommend people to do this kind of curves and surfaces anymore. I think it's kind of outdated, but yeah, if you do, this is the book you want. Next we have Morita, Geometry of Differential Forms, which is all about algebraic topology, but with differential forms. So it covers manifolds, it covers differential forms, it covers the Ram theorem, Laplacian and harmonic forms. Then it has vector bundles and characteristic classes. It has fiber bundles and characteristic classes. It's a nice book, but already very advanced. Should really only do that if you are already very familiar with differential geometry and what they're trying to accomplish, like their goal. Like homology is freely used. Really don't go in this book too soon or you get surprised.